Happy second day of classes. I don't know if I got everybody. I have few people that I didn't check here. I usually check names few times until I know you, put the name to the face. I like to know everybody and their names. So I have few people here that are not checked in here yet. So if I didn't see you, I didn't check you or talk to you, please come see Rachel at the end of class so she can mark your the check next to your name. Okay, so welcome everybody. So I am Pam Ismail. I go by Pam, no formalities. And I'm looking forward to a new food analysis semester. So hopefully you'll enjoy the class. It's going to be a very busy class, but busy in a good way, I hope, for 99.9% of you. The 0.1% does not exist, but in statistics there's no 100%. So anyway, so we'll get started. I want to make sure you are familiar with Canvas and what information you can find on Canvas, and then I'll give you a brief introduction to what the course entails, and then I'll talk more about the lab in the lab, and then we'll start with the intro and see how long we can go with that intro lecture. So, okay, so all of you should have access to the Canvas. So if you go to your courses, first off, so you'll find the course. It is both for the 4312 and for the graduates 5312, so this would be the class website. And then here is just the main page, the information of the class schedule. Okay, this is an error, carry over from last year. There is a Monday lab. So whoever is registered in Monday lab, there is a Monday lab. I'll make sure I add that Monday. And then I'll be your main instructor. There will be one guest lecturer, which is who is Gary, Dr. Gary Renexis, will give you the GC portion of the class as well as the mass spectrometry portion. So I'll be teaching everything else. And then we have a whole crew for the lab that will be working with you. We have our wonderful lab coordinator, Cindy Gallagher, in the back. She coordinates the lab and makes a wonderful lab experience for everybody. And then we have experienced and returning TAs with us. Rachel Metase, right there, PhD student with me. Lucy Hansen, returning TA, master's student with me and sat in this class 2 years ago. Ben Nellis, a recent master's student with me and took the class again in this class, 3 years ago?
Yeah, all 20 years.
And then Allie, just starting and took this class just last year, so she's very geared with food analysis right now. We also have Mu Young-U. Where is she?
She's lost.
She's lost.
I don't know if she knows where the class is.
Okay. All right, so she's also a TA. So we have, as you can see, we have lots of TAs and an experienced coordinator. So the lab is important, and you will feel the help that will get you through this class. It's a lot of backstage work to get the lab in ship shape for you guys to get a good experience. So you'll be interacting with everybody in this class here. And then, let's see, we go to modules, and then you'll find everything there. So if you go to modules, you'll find all the general course information here. So you'll have the syllabus and schedule and student learning outcome. So I'll go through the syllabus briefly in a minute. The schedule also shows you every the title of every lecture and the date and the labs and all this useful information, as well as the final exam. And then the student learning outcome, I'll show it to you in a minute. It's a bunch of outcomes that by the end of the class you would be able to have a good grasp of knowledge and performance. So, and then it helps as a study guide. So whenever there is a section, since I'm talking about it, let me just show you what it is if you have not looked at it yet. So it really helps when you're learning a specific section to go back and look at it and say, oh yeah, I know all of this information, I'm ready for the test. Oh, it actually opened here for me. I'll just move it. I'll move it to the screen here. So there is a bunch of overall student learning outcome for the entire class. And then there is section specific. So specific for the first chapters that are introductory chapters. And then you have specific for chromatography. And then you have specific for spectroscopy, spectrometry. And then compositional analysis. And general chemical properties and characteristics. And that's it. Piece of cake. Yeah, you can laugh. It's okay. Laughing is allowed in this class. Okay. Going back to modules again. So you'll see that we also have lab information guide. And then here you'll find all the introductory information that you need, and I'll go through them in detail in the lab on Monday and Wednesday. So we're going to talk about lab reports, your favorite part of the course, and how to do the formatting, the grading, general lab safety information. So we'll talk about that in lab. And then going back to modules, you'll see here that I posted sample quizzes and exams. And these are the exact quizzes and exams that I had last year for the class. So there is, that is not very good, happened. So somebody was giving a lecture here before and they didn't turn it off, so the system became warm, I guess. Cool down is in progress. We have 24 seconds. Ah.
Are you going to move to that?
Yes, I'm getting to that. I'll do that. Don't worry. Where was I? What was on the screen? Yeah, sample quizzes and exams. So basically you'll have a sample, we'll have 3 quizzes and 1 midterm and a final. So you'll find all 3 quizzes and an exam from last year, and you find them without a key and with a key. So when you're studying for a quiz or an exam, I encourage you to look at the one without a key yet, try to solve it, and then look at the key. The questions will be similar, but obviously not the same. So you just kind of know what level of detail is required, what kind of information I would ask you about, and the such. Well now, let's see if it's going to turn. Now warm-up is in progress. So, great. So also on Canvas, while we have this issue, it would be very helpful when you come to the lab to have your laptop. It's good to mention it now that you would have your laptop and so you can see everything in front of you on Canvas and for entering data in the lab as well. Other than sample quizzes and exams, here we go. I hope it doesn't go out now. You will also find textbook study questions. So for every chapter there will be study questions, so you can look at them, study from them. I have the key in my office, so if you have any questions or you want to know the answer of any particular question that you're not able to find in the book or find easily in the book, you can come see me and I'll show you my binder with all of the key for these questions. Now every week when you turn in your lab report and when everybody turns in lab report and we grade the lab report, we will post a sample lab report here. The reason we do that is if you want to see an example lab report that got full mark and what you did not so well and what others did well, so this would be kind of an example for you for the next lab report you submit. And for the very first lab report, I bring it to lab with me. I bring you an example to lab and have you look at it before you submit the first lab report. So I have you do that, and then from there on, you would just see the lab report of the previous week while you're preparing the new one. So I will post them as we go, weekly here. And also after we all submit your lab report, I'll post the question key. Every lab report has a set of questions. You'll answer them, and then we'll have a key. And because this is a laboratory class, in the exams, I put a lot of questions that come from the lab. So you would want to look at the key so that you are able to answer questions that might come on the exam. And then I give you quizzes, obviously, and exams, and I'll post the key as we have it, as we formulate it, and then once you get your test back, you can look at it and come see me if you have questions. So this is all the general information of the class, but then you will see weekly information. So for student view, you'll see what I show you, what I publish. So you'll see for every week I will publish lecture material. You'll have all of the slides. And then you will have lab material. And then I will talk about that in a minute, lecture versus lab. And you will also see recorded lectures. So these are from last year. You won't see those. I have them as backup in case sometimes the recording fails. I have the previous year recording. So I'm recording the lecture and I will post it here for you. And then sometimes I have practice problems I post under that week. Sometimes I post key of practice problems. So this is for every week. You'll find the information you need for that particular week. Okay. Now, for this class, you will need a textbook. This is the edition, the latest edition, which is, I believe, the 5th edition. And then this is the lab manual. So we have about 6 labs that we need the manual for it, and then other labs we have produced kind of an addendum, we call it, like the laboratory exercise, that we will post under lab material. So if, like this next week, we will be using the manual, the week after we will be using the manual, and then after that we will have an addendum that we will post here. And then another thing that you can have is a lecture packet. Cindy, you want to show them what it looks like, the lecture packet? So we have few of those printed. It's an option. So if you don't want to every day come and print, or you don't want to have your laptop, you can purchase that, and it has all of the lecture information and notes. So it's up to you. It's not mandatory, but it's available if you want it. Now back to lab. So for example, for every week you have to go there, and then you'll find a pre-lab quiz. And this pre-lab quiz, the intent of it, it's not hard, it's very simple, it doesn't take a lot of time, but the intent of it is to have you read the material before you come to lab, so that you know what the experiment is about. Don't come and not be prepared. So it just kind of gives you an encouragement to read the experiment ahead of time. And then we call it pre-lab. That means you turn it in the morning of. So if you're a Monday group, you turn it in 9:30 in the morning to the TA in the lab. And then if it's Wednesday, you turn it on Wednesday at 9:30 in the morning. Do not turn it in at 5. That's pre-lab, not post-lab. Okay, so we really want it to be turned in prior to the lab. So usually I have it available as early as I can in the week, but definitely by Friday. By Friday, this will be up, for sure. I try to put it up earlier, and if I forget, feel free to email me, Pam, can you please post the pre-lab quiz? Sure, I can, I will post it. And then there will be laboratory introductions that we post as well. So when you come to the lab, we have a small, like a short PowerPoint slide on what was going to happen in the lab. We also post that, and handout, if there is a handout, we post that. So everything related to the lab, you'll find it in this lab folder. Okay. Of course, there's a lot more about the lab that I'll cover during lab next week. So I guess this is all about Canvas. I'll try to post grades as often as I can, so you can access your grades. If you need to know your grades and I didn't post them, you're welcome to come see me about your grades and remind me to post the grades. I will try to do that as often as possible. Okay, so this is Canvas. Now, do you have any questions about Canvas? You know? Yes?
Oh, not about Canvas, about textbook.
Yes.
Is earlier edition allowed, like 4th edition?
So, well, here's the thing. So, earlier edition is not like allowed or not allowed. It's allowed, but the material is different, slightly different. The reason of having new editions is chapters change, new chapters are added, old information with analysis. They always renew methods and regulation changes. So, it's better to have access to it. But I know that through the library there is online version. You don't have to purchase if you don't want it. You have access to both laboratory manual and textbook online through the library. So you can log in with your ID and you would have access to it. And if you can't, there's a problem, contact the librarian. You should be able to have access to it. It's a good textbook to own, but you don't have to. Okay. Any other questions? You can, anytime, you can ask me or make a comment or anything. Okay, so where is that? Okay. So I want to mention something. Well, actually, I'll mention it as I go to the syllabus here a little bit. I talked about most everything in the beginning of the syllabus, but let me go back and pull out the syllabus here really quick. I want to highlight a couple of things. So this, I corrected this to show that we have a Monday lab. So Monday and Wednesday are the labs. The one thing different this year is we have construction in ABLMS. So the teaching lab is out of commission for us this fall. So we have a special place in the basement of food science and nutrition. It's actually a research laboratory, but Cindy converted half of it to a teaching lab. It's very cozy, but will function really well. And we will be meeting there for the lab, but prior to going there, Cindy reserved room 23 in the basement for our half an hour or so of introductions to the lab. So we will be meeting in room 23 on the day of the lab, on Monday and on Wednesday, and then we will all go to 65. It's in the basement, both of them are in the basement, just like a minute away from each other or less. So yeah, I will remind you every week of where we're meeting. For example, this week we'll meet in room 23 and the lab will actually be in the computer room because it's nutrition labeling. So we'll tell you exactly where to go. So we have the required textbook and there are suggested references that you will be referring to throughout when you are doing your lab reports, working on your lab reports and such. You will be referring to other references. And I'll talk more about the laboratory in the lab, but also you'll find the course objectives, the university student learning outcome, lecture topics, laboratory topics. The one thing I want to highlight, you all probably know, it's a writing intensive class. So this means there's lots of writing, but the main writing is in your lab report, is your main writing. But there is help on campus with writing. And I usually, when you have a full lab report, that means a lab report, I have partial and full, and I'll talk about that during lab. But when there is a full lab report, you have at least 9 days to complete the lab report after the experiment. So you have time to write it and then go seek help from the writing center if you need to, because you will be graded on writing and we will give you feedback to improve your scientific writing throughout the semester. So you have resources here that will help you if you need them. So I have all of the resources or where to find help. And then So the assignments, we have 3 quizzes, each worth 30 points, and then we have 1 midterm worth 100 points. Let me tell you, you are a lucky group, because 2 years ago or 3 years ago, when Ben took the class or when Lucy took the class, we had 4 quizzes, 2 midterms, and a final. Yeah. So consider yourself lucky. And there was a project. Yes, they're nodding and they're not liking me right now. It's like, you had us do a project. Anyway, and then you'll see that lab reports have 260 points out of 800. So a little bit more than a quarter. So this means it's the bulk of the course. Do well on your lab report, you'll do well in the class. So lab reports are important because it's a laboratory class, so it's a big portion of the class. So the pre-lab take-home quizzes are worth 50 points. You will be maintaining a laboratory notebook, and I'll talk about that during lab. Bring a lab notebook with you. It doesn't have to be of any specific kind. Any notebook will work. Just whatever you're comfortable with, bring it to lab with you, and I'll talk about what goes in your laboratory notebook. And then, this is an important thing. I mean, I'm talking right now, right? I'm talking at you. But I really like you to talk back at me. So ask questions, give me comments, answer questions that I pose. Please talk. I would like it to be an interactive class, and it will be rewarded sometimes by participation points, other times by candy. You don't know. It just depends on my mood when I come to this class. If it's Halloween, I probably come with leftover Halloween candy. So please talk, participate. So I'd like it to be an engaged class. And then overall involvement. I mean, I take attendance, but it's not to force you. You're all adults. You are all responsible for yourself. First of all, I take attendance so that I get to know you, and also to know the level of involvement and interest you have in this class. Okay. And then there are more description on quizzes and exams, what goes into it, the makeup, and then how to make up an exam or quiz. And then lab reports and attending labs is mandatory. No excuse for not coming to the lab unless you are sick or there's some other university-approved excuse for not attending labs. And then lab reports should be submitted on time. If they are late without an excuse, there will be a deduction of points. So please read this so that I don't have to read all of this word by word, so that you know all the details you need to know. There will be extra credit. So extra credit usually is in the form of homework. So it's not necessarily homework. I give you a set of practice problems. If you want to solve them, you can get extra credit. If you don't want to solve them, you don't have to solve them. They're not part of your grade. But it will be helpful because it helps you learn. So, and then you get extra credit for that. And sometimes I walk in and I say, whoever is in the room will get an additional, 10 points, 10 extra credit for whoever is in the class at any random day. Okay. And this is the distribution of the grade. And then please read the syllabus. I know it's boring, but it will help understanding what it takes. Okay. Let's see. So we talked about all of this, student learning outcome, labs. I'll talk about them in detail next week. I showed you where the previous quizzes and exams, textbooks, sample lab reports. Lucky you, no project. It used to be a semester-long project that students would write about ingredients and then processing and then final product and what type of tests are done throughout. It's in my mind, it's a very beneficial exercise because it really helps you understand what it takes to go through from ingredient to a product and what it takes to maintain quality and what tests goes into it. I put an example project online on campus. If you're really curious, you can go and see what type of project students used to do. I took it out for several reasons. One main reason is the students' time. So they always said this class should be 5 credits because of the project instead of 4 credits. And then it took a lot of my time. I do one-on-one meetings and grading first draft and then the last draft and all of that. So it was very time consuming for me and for the students. So I'm experimenting without it. We'll see. If I get students telling me, please bring it back, I will. So let me know at the end of the semester. Okay. Let me do some survey with you guys. What did you hear about food analysis? Who says it's hard? Who is afraid to say it's hard? Anybody thinks it's easy? Who says it's easy? +2 for whoever says it's easy. Great. I can't bribe you. Good. Well, it is harder probably than some classes, just because, think about it, it's 4 credit, it is writing intensive, it's lecture and lab, so obviously it's going to be a little bit involved. I'll try to make it as easy as I can by being available, by answering your question, by making the material, useful to some of you. Is it going to haunt you at night? Yeah. Guaranteed. But in a positive way. Is it going to challenge you? No. Yes, it's going to challenge you. Is it going to be boring? For 0.01% of you will find it boring. That is not an existing percentage. No, some people, material might not be as interesting, which is individual. Some people will find it interesting. Other people will find this is not my cup of tea. But, it is what it is. It's a required class. I'm sorry if you're going to find it boring. Well, I can confess some topics I don't like very much. You will feel it when I come into the class and there's this one topic that I really don't like. You're going to sense it's a different instructor coming to the lab. So, it's a preference thing. Is it going to be useless? You're going to learn something. Maybe 10% might be useful for you in the future. But I guarantee you're going to find something useful in this class. And I'll point it out throughout to remind you how useful this class is. I'll be pointing it out throughout. Okay, so let's dive into some introduction to the entire class, really. Okay, so when you hear food analysis, what do you think? Is it about chemical analysis? Is it about physical, microbial, or sensory analysis? When you hear food analysis. Okay, and when you want to answer, say your name, because we're counting participation until we all know your names. So raise hand, say your name, don't be shy. It doesn't matter if it's the wrong answer. So say your name first.
My name is Paige. And I would say all of the above.
You're going to say all of the above. Laura, were you going to say something
I was
different?
going to say the same, all the above.
Yes, it is all of the above. Food analysis really comprises all of that. But what are we going to learn in this class is the chemical analysis and characterization of components. You'll find some physical analysis chapters in the book, but time does not permit us to cover all 30-some chapters, so we won't be able to do that. But under physical analysis like microscopy, for example, or measuring of color and texture, these are all physical analyses. So, but we won't get to them, but there are some chapters that are very helpful in the book. If you are curious, you can find them. Of course, there's a food microbiology lab, and there's a sensory evaluation class. So we won't cover those here. So why do we carry, first of all, what is food composition? What's the definition of food composition? Don't be shy. Anything can be correct for this. Yeah, Sophie?
So it could be nutrients, like either vitamins or macronutrients, for the ingredients themselves?
Yeah. So food composition can include what Sophie said is can include the actual micronutrients and macronutrients, microvitamins and minerals. Macro is your carbohydrate, fat, protein, water. So these, and then other composition can also be these contaminants of concern, like contaminants you don't want. You might have some residues in there that you don't want, like pesticides or mycotoxins or what have you. So why do we measure these, or why do we care about analysis of food composition? Say your name.
Brigida.
Brigida.
It's all the above.
It is all the above. Yes, definitely. So we'll talk about all of this. We'll talk about what the consumers are demanding, what the government requirements are, what nutritional benefits we look for, as well as overall quality control of the entire process, from ingredients or raw material all the way to production of products or production of ingredients from raw material. So all of this, we will give examples about why food composition analysis is important. So we'll start with from a consumer perspective. So we go, why do we need to analyze food or look at the composition of food or the characteristic of food, not just composition. Sometimes we're looking at texture, flavor, rancidity measures. So it's not always the components, sometimes the reaction after a certain process. So consumers, what do they care for? They care for quality, number one. They want consistent product. They want high quality. They want something that tastes good, looks good, and lasts for a long time on their shelf. And they want to go, when they buy their cereal from General Mills, the Cheerios, every time they buy it, they want it to taste the same, have the same structure, have the same characteristics. So they look for consistency in their product. Obviously, they care for their safety, so they don't want any contaminants, whether it's microbial or chemical contaminants. And we have a whole chapter on chemical contaminants. So they care for their safety, and they also care for their health. So they probably want to make sure they consume the right amount of protein, the right amount of calcium or vitamin D. So they want the right amount of nutrients in their diet, as well as some health. Like they probably, now what's the most trendy thing consumers are looking for? High protein. Brigida. Yes, high protein. Anybody else thought of another trend?
No sugar.
No sugar. What's your name?
Mom.
MUATH, right? Yeah. No sugar, low sugar. What else? Jason.
Kind of like the high protein substitution.
Protein substitution. So vegan versus animal. Yes. Laura? Gluten-free. This is a myth. Well, some people have sensitivity to gluten, but not everybody has. And it became like the population think that gluten is toxic now. And then now you go to the market and you get a bar that is not made of nuts, and it says on it gluten-free. What? It's nuts and sugar. Of course, it doesn't have gluten. It became a marketing thing. What else? Say your name first. Sammy. Yeah.
Along those lines, I'm dairy-free.
Dairy-free for allergen. Okay, so I'm going to say for allergenic purposes. Some people avoid eggs, dairy, wheat. We have 8 allergens. Soy, shellfish, nuts, tree nuts, peanuts, all of this. And then, yeah, high calcium, for example, for osteoporosis. And you have a whole lot of different health claims that the consumers are going after. So the industry kind of address these demands and make sure that they analyze their food so that they can make the right claims. Okay, so a health claim related to coronary heart disease may involve the analysis of the following. Coronary heart disease. Which of the following do you think would be important to make that health claim? Which is very common? Which one of these stand out? Saturated fat. What about the others? definitely. Yes, phytochemicals. So that is good. What about free fatty acids? Is this important? No. Why do you say no? Remind me again of your name. Name. Paige. It doesn't seem right. No, it doesn't seem right. Where, in which instance we want to measure free fatty acids? For what purpose? Who took chemical reactions before food analysis? Shelf life. Thank you. Say your name. Amen. So, yes, shelf life. So, free fatty acid is a measure of hydrolytic acidity. So, if you've taken food chemistry, you should know that. If you're taking food chemistry now, you will learn that. So, free fatty acid is the product of when the fat breaks down by hydrolytic acidity by action of enzymes like lipase. Or if you have water and heat and oil, like you're frying the potato in oil, you will end up getting free fatty acid due to hydrolytic rancidity without enzymes. So this is a measure of rancidity. So when we have a purpose of measuring shelf life or rancidity development, we measure free fatty acid, and this is one exercise you're going to be doing in lab, and we'll be covering in class under fat characterization. Okay. So from food industry perspective, why do we analyze food? So again, industry want to ensure product quality. So they have specification, whether they're producing an ingredient or producing a product. They have a specification quality for their product, so they want to maintain it. Maintain it at similar moisture level. So you don't have, for example, if it's a Cheerio, you don't want it to go soggy over time. So you want to maintain a certain moisture level, a certain amount of nutrients, so a certain texture, flavor. You want to make sure that the product quality is acceptable by the consumer and is following the regulations and the control products for that industry. Product development, I'll give you an example for product development in a minute. So if you're doing R&D development, research and development, producing new product, so there is a set of analyses that you would be needing to do, and I'll give you an example. So all of this is to meet consumer demand. So the consumer requests high quality. The consumer is always looking for new product, new exciting food product out in the market that meets their demands, whether it is high protein, low sugar, low salt. They're always looking for these products, so there's always going to be product development. Evaluate new processes, and I'll give you an example. So installing a new instrument, for example, or new, not instrument, what is it? Processor or machinery in your industry. So I'll give you an example of that. How will this change your product? And then, why do they do that? They're always looking to reduce cost and increase profit. So they're always looking for efficiency, and they're always looking for new machinery that will provide them with lower cost, higher throughput, and of course with lower cost they have higher profit. But they need to know how that new process will impact the food itself. Solve problems. So we call this food forensics. So forensics, it's a cool, exciting term, but even in food you have forensics. That means you're searching for the what's behind that problem. So you use your analytical tool to determine where that problem comes from. Problem could be, I'll give you an example, but it comes from the customer. So if you're a supplier, an ingredient supplier, and then the customer that produces with your ingredient comes to you and tell you, well, there is a problem with the product, and we think the problem is from your ingredients. So you go back and do some forensics analysis to determine where the problem is and try to solve it. And obviously, competition. So in industry, everybody is competing to produce the better product, the more profitable product. So there is analysis so that you look into a competitor product to see how you can develop similar product and get profit and a size in the market. While they're doing all of that, they have to follow government regulations. So there are regulations in terms of production of food. There are regulations in terms of choice of method. that you use for their purpose. So we learn about that as we go. So government regulation is kind of overarching everything. So here are some examples for product development. So let's read this together and think about it for a minute and try to tell me what analysis we're going to do. So as a food scientist in the R&D department, you were asked by the management to replace butter with vegetable fat in order to reduce cost. What food analysis test will be involved in this process? You can list any food analysis test. Yes, tell me your name first.
My name is William. I would do a sensory test for consumers, make sure there's no change in the texture.
Yeah, texture and flavor. Yes. What else?
A microbiome and shelf life test.
I'm going to catch the shelf life. So you can do microbiome to see how from a microbiological standpoint, the shelf life, but the shelf life is key for something else. POH, right? Yeah, POH. Yeah? Lipid oxidation. What's different from vegetable fat? How is it different from butter in fat characteristics? With chemistry people, whoever do.
Saturation.
Degree of saturation. So if you have a vegetable oil, you have higher level of unsaturated fatty acid. And unsaturated fatty acids are more prone to oxidation than saturated fatty acids. So we have a whole lab on that as well towards the end of the semester. So yes, so we're changing butter, replacing it by vegetable oil. The characteristic of the oil or the fat is different. We need to check shelf life. Taste is very important. Microbiology is very important. So yeah, good. Evaluating new processes. So you are in charge of soy flour quality. Soy flour is rich in protein. It's about 40% protein. It's really high in protein. And your product line will have a new cooker. That's an example of having a new equipment, machinery. Better temperature and time control, so efficiency. So you move the old cooker and you put down the new cooker. What food analysis test will be involved in this case to ensure product quality? You want to make sure, actually this is an example I got you from when I was working at Cargill. So they had this problem where their soy flour was sent for fermentation, to be used in fermentation for producing of yeast. So during fermentation, the yeast was feeding on the soy flour, and they noticed that there was difference in growth of the yeast when they changed the cooker. So, of course, they wanted to know why, so we started doing some forensics on the subject, and we started looking, okay, so soy flour, different cooker, high in protein. What do you think? What analyses do you want to think of? Yes? The consistency of the product. What consistency specifically? Yes, consistency of the product is correct. Did you get his name, Rachel? Okay.
Texture.
Well, you're getting there. You're close. But with soy flour, there's not much of a texture. You have protein in there. Yeah?
Since you have protein, I think protein is.
Really that.
Yes.
Mhm.
I think protein is quite sensitive to high temperature, so
Yes.
we have to know what temperature is the optimal.
You're very right. So the protein is sensitive to high temperature. So if there's any change in time and temperature control, the protein might denature. And when the protein denature, it might aggregate, polymerize. That goes back to the texture thing. And then when it aggregates, a very important quality is deteriorated, and that is the digestibility of that protein. So the ability for that protein to be broken down by enzymes. So yes, so that's what we look at. What changed in the protein? And monitor that change and try to regulate temperature and time to go back to the original protein quality when the old cooker was used. Okay. Product complaints. Oh, that is a lot. There's always complaints, and it's always not our fault, their fault. Okay, so you have a serial-based pellet that was sold to various customers. So you are a producer of a pellet. The customers get the pellet, they deep fry it potentially, and then they pack it, and then they sell it. So sell it as a snack food. So the customer complained that the finished product was rancid. You obtain packages of the product. So obviously you want to go and see what the problem is. So you got packages of this product, and now what could be, first you start thinking, what could be the reasons of the problem? And what tests you need to know to confirm that this is the reason of the problem? So can you think of what could be the reason of the problem? So you have the pellet, you have the frying in the oil, and then you have the package. What could have happened that could have led to rancidity? She's Sam, but stick. So we have two Sam and one Sammy. Okay.
Package failure.
Package failure, that is one important thing. So the package might be, well, it's broken, it can be permeable to oxygen. So obviously this product has been fried with oil. So, and then you have oil and you have oxygen, then you get oxidative rancidity. You can test that by looking at peroxides and secondary metabolite of oxidation, and that is the subject of another chapter. Okay, so that is one thing, looking at the package. What other thing can be? Can you tell me your name again?
April.
April.
Like water activity.
How would water activity impact?
If when they're frying it, there's like extra water left in the packaging, it'll become rancid faster.
Yes, so water activity is another thing that you would look at, and we will have a lecture on water activity, and then in chemical reaction we'll talk about shelf life. So yes, that's good. I saw another hand back in the back. Yeah.
Something might be wrong with the oil.
Something might be wrong with the oil. Thank you. And your name?
Maddie.
Maddie. M-A-D-I. Okay. So yes, the oil. I need not only to get the package, I need to tell them, give me a sample of your oil. So you would check free fatty acids in the oil, because that's an indication of how old their oil, how many times they've used their oil and not changed the oil. So you check free fatty acids in the oil, you check also presence of peroxides or secondary metabolite of oxidative rancidity. So you check the oil, you check the package. Very good. Of course you want to check your pellet. You don't want to be overconfident that your pellet is good, so you check your pellet also for oxidative and rancidity measures, hydrolytic rancidity measures. Perfect. Food forensic, we have 1 minute. I'll do that and then I will call it a day. You are a researcher in an ingredient company. One of your customers, a food processor, send you a product formulated with one of your ingredients, it's always one of your ingredients, and tells you that there is a sharp foreign matter in the product. Yes, Jason?
Check your machine and machine operator.
Check the machine operator for what?
Foreign objects that might be.
Yeah, and what tool would you use to look for these sharp foreign objects that could be very small? Well, you can do metal detector, and if it's not a metal, it's something else, what would you do? X-ray, microscopy, I'm going to say specifically. X-ray does not always show you everything. What were you saying? You can do you sieve them and then see if there are any foreign matter, but sometimes it's very small. You won't be able to differentiate if it's a glass or a sugar crystal. To do that, you can do scanning electron microscopy, SEM, or you can do CLSM, which is confocal laser scanning microscopy. And you can use different staining. You can differentiate a sugar crystal from a glass. So you can do a lot of microscopy work to determine this foreign object. Alrighty. Well, I had a good time. I'm not sure about you. See you on Wednesday. Well, no, today is Wednesday.
One thing about X-rays before sorry, I didn't get the name of the one.
Who spoke last? That's Sam, right?
No more.
There was April, Maddie, Paul.
Thank you.
Okay. All right. See you Friday. Yes, this is a question.